How's it going, stat students? This is Mr. Shack, and this is your Chapter 5 review video. It's going to be a quick one. It's going to go really fast, honestly. There's just not too much explanation with basically all of this front side, and then there's just a back side that I think will go pretty quick also. But a lot of it is just like, hey, realize you're using normal CDF here. Here's what your lower bound is. Here's what your upper bound is, and that's that. So I almost debated not making a video for this one and just posting your key, but I figured it's a quick video, won't take too much of my time. So here we go. First one right away, the normal distribution curve never touches which axis? That's your x-axis because it never has a probability of zero anywhere because technically there's a chance for everything. The total area under the normal curve is always one. Okay, total area is one, kind of just like your probabilities have to add up to one. Approximately what percent of a normal population lie within two standard deviations of its mean? That's the empirical rule. It's 68% within one, 95% within two, 99.7% within three. That's the empirical rule. Normal distribution is specified by a mean of zero and a standard deviation of one. Okay, that's the standard normal curve. We talked about that a lot. Hopefully, we got that down. The mean, median, and mode for a normal distribution. If it's a normal distribution, those are all equal to one another. You can write out the word equal sign, whatever makes you happy. As you go to 6, in the central limit theorem for the sample mean, if the original population is not normally distributed, then the sampling distribution will be either exactly or approximately normally distributed, provided that the sample size is large enough. Well, if it's large enough, we're going to say it's approximately normal. We can never say it's going to be exactly normal. The larger, the more normal it gets, but we always say approximately normal. Okay, the distribution. Wow, talking is hard this morning. Distribution of sample proportions will be approximately normal if the sample size is greater or smaller than 30. That's greater than, right? As we increase our sample size, the less spread out it gets and the more normal it gets, therefore. And that's kind of what 8 is talking about. As the sample size increases, the standard deviation for the sample distribution of sample means when samples are taken from a single population will decrease. Okay, again, that's kind of a lot of words, lots of sample, and just like words, but it's gonna get less spread out the more that you increase the sample size, which if it's getting less spread out, that means your standard deviation is going down. Okay. The central limit theorem for the sample mean applies to some, only discrete, only continuous, or all distributions from which samples are taken. It is all distributions. All distributions does not just have to be continuous, does not just have to be discrete. It's all distributions. Okay, find the area under the standard normal curve to the left of z equals 0. Well, for this one, honestly, you don't even need your calculator. If you're talking the standard normal curve, the z-score of 0 is right in the middle. Okay, and the area under the standard normal curve to the left of z equals 0. Well, if z is 0 right in the middle, and we said the whole curve has an area of 1 under it, well then if 0 is in the middle, then to the left of that would be 0.5, and to the right of it would also be 0.5. Okay, if you wanted to do that in your calculator with 0 as your upper bound, negative 1,000 as your lower bound, you could have, and you would get 0.5 that way also. Okay, find the area under the standard normal curve to the left of z equals negative 0.27. Okay, for all of these, notice they're standard normal curves. Okay, so when that's the case, that means mu, and I'm just going to say it once. I'm not going to say it for all of these, but it means mu is 0, your mean is 0, and your standard deviation is 1 for all of these. So really, for all of these, I'm just going to the normal CDF function. Okay, normal CDF function, and I just have to do lower bound, upper bound. Okay, and mu and sigma is always 0 comma 1, which that's what your calculator should have defaulted into it. So like for this one, I'm just doing normal CDF of, we're going to the left of negative 0.27, so all the way to the left we call negative 1,000. That's going to be your lower bound. Your upper bound is negative 0.27. Okay, and then you could put in 0, 1 if you're unsure if your calculator already has that in. Depending on the calculator, it might show you that it already has that in. If you have the older calculator, you should be good. And here's an example of the older calculator. You're going, oops, you can't see. Here we go. You're going second vars, normal CDF, and then lower bound negative 1,000. Okay, comma, which is right above the 7. There's a glare, you can hardly see. Maybe that's a little bit better. Comma, and then our upper bound is negative 0.27. I'm not going to put in the 0, 1 because I know this calculator defaults to having a mean of 0 and a standard deviation of 1. You should get 0.39. Oops, that's this one. 0.3936 when you round. Okay, and again, for all of these, mu and sigma are 0 and 1. So mean of 0, standard deviation of 1 for all of these. If we're talking to the right of z equaling 1.68, I'm bad at multitasking, writing and talking at the same time, then your lower bound is 1.68. Your upper bound we call positive 1,000. That's what you're putting in. I'm going to start going faster through these. You should get 0.0465 there. Okay, again, it's really just you're doing this over and over for these. Normal CDF, lower bound, upper bound, mean is 0, standard deviation is 1. Okay, we're talking between two. Okay, well, that's still going to be normal CDF. And now your lower bound is the negative 1.96. Your upper bound is the positive 1.96. Mu and sigma still 0. So again, I don't even have to put that in my calculator because this is a standard normal curve. You should get 0.95. Okay, find the indicated probability using the standard normal distribution. Well, now, yeah, it's worded a little bit different, saying like what's the probability that your z-score is less than 1.28, but you're still doing the same thing. It's still normal CDF of, because you're finding the area to the left of 1.28. You're finding like what percentage is to the left of the z-score of 1.28, and that tells you your probability. So it's still now we're left of positive 1.28. So all the way left we call negative 1,000. That 1.28 is your upper bound. Again, still standard normal. So mu is still 0, sigma still 1. So you don't even have to put those in, and you should get 0.8997. Okay, and lastly, on this page, we have standard normal distribution. Find the probability that z is greater than 0.74. So again, still norm CDF. And then lower bound is now negative 0.74. Your upper bound going up to 1,000. Again, mean of 0 still, standard deviation of 1 still. When you put that in, you should get 0.77. Ooh, I realize it's kind of hard to see on the screen. 0.7704. Okay, it's at the very bottom right of your screen. You can see, I guess, barely though. Okay, let's flip this over and get to the back. On the back, we start talking about percentiles right away. So find the z-score that corresponds to the 20th percentile. Okay, when you are finding a z-score, you are using inverse norm. Okay, inverse norm, unless you're given like z equals like x minus mu over 6. So if you're given a raw score, you're given a mean and you're given a standard deviation, well, then you can use that formula, that z equals x minus mu over 6. That's what we'll be doing here in 18, actually. But in this case, we're just given a percentile. So you're saying, like, what is the z-score that corresponds with the 20th percentile? Well, 20th percentile is going to be 0.2, right, or 0.20, you can think of it. So it's going to be like, what's a good way of saying this? 20% of the curve will be under this z-score is what that's meaning. So inverse norm of 0.2, you just put that in your calculator, you should get negative 0.8416. Okay, find the z-value to the right of the mean so that 75.1% of the area under the distribution curve lies to the left of it. Okay, it's saying to the right of the mean because this is greater than 50%, so that's going to be to the right of the mean. Don't let that word right throw you off. It's still under the distribution curve lies to the left of it. So that still means you're doing inverse norm of, okay, again, you put in the number so we're saying like 75.1% lies to the left of it, so that's 0.751 that you're putting in for your inverse norm, and you should get 0.6776. Okay. That's that. As we get to 18, well, now we have a bunch more information coming out, and we're going to have to find z-scores from getting different type of information. Each month, an American household generates an average of 30 pounds. Okay, average of 30 pounds, that's going to be your mean. It says average. For garbage or recycling, assume that the standard deviation is 2, so there is your standard deviation. If a household is selected at random, find the probability of generating 29 and 32 pounds per month. Okay, so we're going to find the z-score that goes with 29. We're going to find the z-score that goes with 32. And in this, we are using the fact that z equals x minus mu over sig, which we talked about way back in chapter 2. Okay, so we are using this again. And first I'll do the 29, so that's going to be 29 minus 30 over 2. Okay, and when you do that, that's negative 0.5. Then this one I'll do the 32, so that'll be 32 minus 30 over 2. Again, x minus mu over sig, which sig is 2, mu is 30. 32 minus 30 over 2, well, that's going to be 2 over 2. When you do 32 minus 30, that's 2, divided by 2 is 1. So you get z equals 1. Okay, now in order to find this probability here, you have a couple options actually. You can use the raw scores of 29 and 32, so that's the first route you could go. And you could say I'm going to do normal CDF of lower bound, upper bound, mu 6. So my lower bound in this case would be 29, my upper bound would be 32, and then if I'm using these raw scores, those raw scores have a mean of 30 and a standard deviation of 2. That's one option that you could put that in your calculator. Or you could say, well, we already found the z-scores, so I want to use the standard normal curve, which is going to be normal CDF, and then your lower z-score is negative 0.5, upper z-score is 1, and then since you're using the z-scores, that's where you have a mean of 0 and a standard deviation of 1. Either route, if you enter either of these in, you're going to get the same answer if you do it correctly, and that's 0.5328. So that means 53.28% fall between 29 and 32 pounds per month. Okay, on to 19. 19, we are qualifying for a police academy candidates, or in order to qualify for a police academy, candidates must score in the top 10%. Okay, the top 10%, well, that's really like saying the 90th percentile, which means 90% is to the left of it. So right away when I see that, and I'm assuming I'm going to have to find a z-score, so the z that corresponds with the 90th percentile, so it's inverse norm, and again, if the top 10%, that really means 90th percentile, which that's important because you're saying the area to the left, which would be 90%, in other words, 0.9, and that's 1.28. I'll go to the third place, 1.282 if we want to go to the thousandths. Okay, and then from there, you're using the fact, because you're trying to find the lowest possible score to qualify, and you know you have a mean of 200, you know you have a standard deviation of 20, okay, and you're trying to find the lowest possible score that qualifies. So you're trying to find an x value, you're trying to find the raw score, which you know you can find raw scores by doing mu plus z sig. Okay, mu plus z sig. Well, we have our mean now, so that's 200, right? That was given to us. We have our z-score, that's what we just found using the inverse norm, okay, and that was 1.282, and then that needs to be multiplied by the sigma, which is 20. Okay, when you do that, you should get 225.6, and that's your lowest possible score that you need to qualify. Okay, so you're first having to find your z-score that corresponds with the top 10%. That's what we did. Once we had that, we're able to use the fact that your raw score equals mean plus z-score times your standard deviation, mu plus z-sig. Okay, so you find your z. Once you have that, you have all three things you need. That will give you your x, your raw score. Okay, Heather's z-score on a college exam is, I'm just trying to scroll here so that everything's on your screen. Heather's z-score on a college exam is 1.6. If the raw scores have a mean of 380, okay, let's go mean of 380. They already said her z-score is 1.6. Okay, and a standard deviation of 70. Okay, what is her raw score? Well, when you're finding a raw score, it's mu plus z sig. Mu plus z sig. We got all three of those things. So it's as simple as going, what did I just say? Mu, that's 380, plus z, which is 1.6, times your sigma, which is 70. When you put that in, you should get 492. That's all you're doing there. Not too bad there. Okay. For something like 21, we get into the central limit theorem. A population has a mean of 100, oops, I almost said 1,000, 100, and a standard deviation of 15. Find the mean and standard deviation of a sampling distribution of sample means with sample size of 100. Okay, so n is greater than 30 here, so you know we can use the central limit theorem. Mean of the sample means is going to be the same as the population mean. We've always said that. So your mean is still 100. That's basically 3 points. You're basically given an answer there. Standard deviation is always your population standard deviation divided by the square root of n. Okay, so our population standard deviation is 15 divided by the square root of n. Well, n, it's a sample size of 100. That's the square root of 100, which is really just going to be 15 divided by 10. Which, what is 15 divided by 10? That's 1.5. That's your standard deviation for the sampling distribution of the sample means. Okay. As we get to 22, this really takes us back to chapter 4, which was just your last chapter, so hopefully you haven't forgotten about it yet. We got a magazine reported that 6% of American drivers read the newspaper while driving. 300 drivers are selected at random. Find the probability that exactly 25 say they read the newspaper while driving. Okay, it's nicely laid out for you. You need n. Well, that's your sample size, or the 300 drivers. You can call it trials. That's n. Okay, that's your 300 drivers. Then you need p, which is your probability of success, and the probability of success in this case is the 6% of American drivers that read the newspaper while driving. Okay, we wouldn't really call that a successful thing to do in life, but in this context, that's your p. We're trying to find like how many of these Americans do read the newspaper while driving. So a yes is to yes, they read the newspaper. That's 6% of them, which means the no's and the failures in this case, which is Q, is 1 minus 0.06, which is 0.94. Okay, that's everything we need. N times P, that's 300 times 0.06, and that's 18. Okay, now for B, you got to do N times P times Q. Okay, N times P times Q, so that's 0.06, or sorry, 300 times 0.06 times 0.94. That's 16.92, and then you take the square root of that, which the square root of that you get about 4.113. That's your answer there. Now to find the probability that x equals 25, that's going back into binomial. It's equals 25, so that's when we use PDF, don't forget. And then it's always NPX. Your N is 300. That's your number of trials. P, probability of success in this case, probability of the people that read the newspaper, that's the 0.06. And then your X, that's what you're given here, that's 25. Okay, so when you put that in, you should get 0.0226. And that's your answer there. So it's N, P, and X. For those of you that don't have the menu that pops up that says trials, P, X value. Okay. Lastly, the average age of a vehicle registered in the U.S. is 8 years or 96 months. I'm assuming we're going to be using months if it tells us both. Yeah, assume the standard deviation is 15 months. If a random sample of 25 vehicles is selected, find the probability. Okay, that it's between 80 and 100 months. Okay, so first things first, we need our mean. That is the 96 months. Okay, assume that the standard deviation is 15. Okay, standard deviation is 15. And if a random sample of 25 vehicles, that means n is 25, find the probability that the mean of their age is between 80 and 100. Okay, for finding probabilities like this, that's going to be the normal CDF function. And they give us the lower bound of 80, upper bound of 100. Okay, now here's where we got our mean is 96, but we really need the mean of the sample means in this case. But again, the mean of the sample means is equal to your population mean. Okay, so this 96 really comes, yes, from this 96, but it's technically we're thinking of it as the mean of the sample means in this case. This is a central limit theorem type question. Okay, because it's a random sample of 25 vehicles. Okay, now to find your standard deviation, it's not just 15, remember. Your standard deviation is going to be, so standard deviation of your sample means, okay, that's sig over the square root of n. So this is really going to be 15 over the square root of 25, which really is going to be, well, square root of 25 is 5, so 15 over 5, 15 divided by 5 is really just a 3, okay? That's what you're putting in your calculator. And you could put it in as 15 over square root of 25, and your calculator would do that for you, but we also know square root of 25 is 5, so 15 divided by 5 is 3. So we're really doing normal CDF, lower bound 80, upper bound 100, mu being 96, that's your mean. And your sigma in this case, your standard deviation, remember it's the standard deviation of the sample mean, so that's why we take this sigma and put it over the square root of n. Which is 25 in this case for the 25 vehicles. When you put all that in, you should get 0.9088. Okay, oh, I just realized most of that was cut off. Okay, there you can see everything. Hope you were able to see what I was pointing to. If you got questions about that one, please feel free to ask, as well as any questions on either side of this review. That's your Chapter 5 review. Good luck on your test.